Hi everybody, what's up? Hey Noam,
Hello.
how are you this evening?
Excellent. Who's joined us
I
so
s-
far?
I see some familiar faces, some
Nice.
customers. I think everyone is excited to see one of the founding engineers building dashboards. Something a bit more advanced this time, not the usual demo. So I'm excited. Yeah, so maybe I see still people are joining. Maybe we can take a few minutes. I'm usually talking about how is it for me. Um, uh, who doesn't know me? I'm Chez. I'm the CTO and co-founder of groundcover. And this is Noam. Noam, you can introduce yourself.
Hello, everybody. So yes, my name is Noam Levy, and I joined as one of the first two employees to groundcover from the inception of the company. And, I hope I will help make this webinar a bit more geeky or nerdy and around the product itself. Um,
Yeah,
yes.
cool. So maybe just before we get started with the techie stuff, how is it for you? I'm curious to hear how is it for you, as an engineer spending a lot of years using these kind of tools, these kind of systems, platforms. How is it for you to finally, I don't know, build your own dream tool or making an impact on this industry?
I think so. So I think at the base of it, it all started with the mind shift of looking at a problem not as a consumer, but as someone who now has the privilege to solve it by its own. So, I work with metrics and with traces up until like 2 years ago when we started developing the product. And you get used to all the inconveniences within it. You have your own workarounds, your own special Docker Compose YAMLs that you bring to every workplace with you, all the knowledge you gathered along the way, and suddenly, like, you can address some of those issues that you worked around for years and just solve them yourself. I think for me, the most challenging, but as a result, also the most fun part and the most interesting part in the last 2 years of developing groundcover, I would say it will be definitely two pillars that I think that are very present in groundcover today, is the out-of-the-box experience. So getting a monitoring solution that is not like a result of building blocks you set up individually, one by one, and orchestrated them all to work together.
Mhm.
And so this would be the first thing that comes to my mind. And the second part, of course, is a monitoring system that also produces a lot of data and aggregating it without definitions, predefined user definitions. I say I think it was very challenging because in order to not generate too much noise and to find what are the golden signals that are very relatable to a lot of users that make sense without being familiar with how workloads look, I think it was very interesting because the ground cover at the end of the day is being installed out of nowhere in clusters, and users need to see something that makes sense for them and something that brings them value without them telling ground cover how their metrics looks like, what is a working state of an app. And you can do all the basic stuff like finding errors and HTTP errors, and of course we do all the stuff, but you also want to do like this one extra step that makes it feel like more like, hey, they know my product, they know how it should work, and what's not working. And I think this is something we're still iterating over. And I think once we'll get in the webinar a part where we actually building custom dashboard. I think one of our latest understanding in this effort of like understanding cluster without seeing them before is also adopting the data points that the user has predefined themselves and give them a platform to engage with them together. Like the metrics generated by groundcover, but also those metrics and those traces that they created by themselves for a year before they install Graver, 2 years before they install groundcover, whatever.
Right. Because you don't need to be very intelligent to think, okay, there are Prometheus exporters already defined, with annotation. So obviously we want to scrape them, right? So and also I think this is one of the reasons why we took the leap with ebpf, because we who doesn't know, ground cover is based on very exciting and new sensors based on ebpf, which basically let us create so much data and extract so much data in terms of APIs between microservices, and create on top of that golden signals. Some of them you're going to see in a second with Noam demonstrating how to build custom dashboards. But at the end of the day, we just took some basic principles and we tried to apply it with one simple rule. Everything should be frictionless, right? So everything should work out of the box. Everything should be very easy, because the world today, the cloud native application actually allow us to do that. So we're just taking that further and further and trying to expand the platform. All right, enough with the small talk. Noam, let's show the people what you can do with the platform.
Cool. So I'm going to share my screen now. I'm going to start with a demonstration of groundcover native capabilities. So let's say until I say we're moving to the custom dashboard building, then the custom alerts, all the data and all the investigation that I'm going to go through in the demonstration is based purely on groundcover generated data, which means data that is completely agnostic to your workloads, that does not require any sort of implementation, that does not rely on it in what way, on that way or another. Cool. So I'm going to share. Let's start with the cluster status page. So once you will go to appgroundcover.com, you won't see this screen immediately. There will be an onboarding screen that will take you to, will give you a command to install groundcover on your cluster. This command will install the groundcover CLI, which by the way is also open source. And it's also baked in with your API key that is related to your tenant. Once you install groundcover using this command, after around 2 minutes, the cluster will appear with the auto-detected cluster name. In this case, we use the demo cluster for demonstration, of course. And in a matter of seconds and minutes, a complete workload listing of your application in the cluster will be displayed. So in groundcover, and it's not just in groundcover, but when we try to, let's say, identify an issue, or this is like the classic monitoring question, what's wrong? And if we'll take a broader question that is more tied with how observability is defined today, that is, what is happening in my cluster? So there are two approaches for answering this question. One is a top-down approach, which means like, okay, let's go to my monitoring system and try to see if something goes wrong, something is acting funny, and drill down to it. Or you have a predefined, you know exactly what trace or what metric you want to look at, or some performance benchmark of a freshly deployed workload that you want to understand how the new version impacted the latency, for example. Those two approaches can be addressed, one as top-down and one as bottom-up approach. So when investigating problem top-down, the overview screen and the workload screen and the map screen are your best friends. Overview will give you basically all the workloads identified in the cluster and show in which workloads ground cover has detected an issue. Rainy means there is an issue to investigate. Sunny means no issue is currently detected by ground cover within the time frame stated in the top right corner. Of course, I forgot to mention earlier, as many clusters as you will add to ground cover, they will auto display here. And ground cover installation status will be exposed using this green orb in the bottom right corner. So if something is funny with the ground cover installation, this orb will turn red and it will refer you to our support channel in the Slack community, which you will probably get an answer from me in 5 minutes or less. Cool. So I want to, before I'm drilling down to an issue in our front-end service, I want to take you to a more visualized, let's say a more graphical visualization of your workloads. And this is the map screen. The map screen is the same workloads we saw in the overview screen, visualized with their interaction with every other workload, and also with workloads that are that exist outside of the cluster. Interactions with services that are outside of the cluster will be marked with a small earth orb on the top left corner. In this case, we have a managed AWS MSK, managed Kafka service that all these services are interacting with. This map, as I said earlier, is generated completely, fully with the powers of ebpf, with no instrumentation involved, no mesh network, so we're not relying on some sort of mesh networking solution in place. Usually, some of you might be familiar with map like this produced by Istio or by Linkerd, which will require a sidecar or instrumenting the product. And we do this with ebpf, completely transparent to your workloads. I'm going back to the overview screen, and I'll now drill down into the front-end screen, front-end workload. This workload, so this screen is what we call a workload overview screen. Will show you basically a briefing of what is happening in the workload, in the front-end workload. Some few worthy mention about how ground cover is is defining a workload. So one of our core efforts in ground cover is to simplify the interaction with Kubernetes. A lot of our customers are developers and not DevOps engineers. And for some of them, interacting with the workloads is with the Kubernetes terminology, such as pods or the stateful set or the replica set, can be a bit intimidating and sometimes confusing. In ground cover, we auto-group all the instances of the replica set and we expose a workload object, which in this screen, you can drill down to its Kubernetes components, which you can see here. For example, we display that we identify its replica set and how many pods there are within it and in which namespace it runs, but also screens that are more familiar and more relatable data that is usually more interesting for the developer's point of view. Request per seconds, latencies, error per seconds, and a subset of the map that shows which other microservices this workload is interacting with. Something nice about this map feature is the ability to understand the blast radius of a specific issue. So if we have, usually when we identify an issue with a workload, we would like to know how other workloads might be affected. The subset of the map gives you exactly the essence of which other services might suffer some downtime or regression due to the issue currently occurring in the front-end workload, but also maybe it will show you, it will hint what workload is the root cause for this ongoing issue. In this case, you can see that the issue was detected in the interaction of the front-end workload with the load generator one. Cool. So I'm now going to scroll down a bit, and I'm going to show you like the 5 tabs, the 6 tabs that are presented for every workload once you press on it. This is another core effort here in groundcover, is to bring as much context in one screen as possible. Monitoring is defined by, let's say, we have the Kubernetes context, we have the logs context, we have traces, we have metrics. And usually in other systems or from our experience, this means that when we investigate an issue, we had to move between tabs. We had to, let's say, copy a time frame from the when the issue occurred. We identified the time frame within an issue as occurred, and then we went to another system in another tab, searching for logs for that issue time frame. In groundcover, we try to help you avoid all those unnecessary traveling, like browsing, and bring you all the context you need into a single page. This will be very prominent in other screens as well. So now in the workload, you can see the pods, the infrastructure tab, which will show you the CPU and the memory request usage, and also the defined request and limit for that workload. This is a very effective screen for identifying opportunities for optimizations. One of the most famous Kubernetes problems, especially in a large organization where they have CD procedures that the developers aren't aware of with what memory and CPU definitions the workloads are going to be actually deployed with. So, and this problem is overcommitting. It's when we deploy a service that doesn't necessarily require a lot of memory or CPU, but we give them a high threshold of request and limits, basically causing a lot of nodes to not be fully utilized, and also increase cost for cluster management, especially in clusters that are elastically scaling. I'm going to fast
Noam,
forward.
are you gonna show all that also in the custom dashboard flow?
Yeah, of course. So okay. I'm going to show you now the other the two most important tabs in this place, in this view, is the issues tab, which is the issues that basically brought us here in the first place. And you can see that groundcover identified 2 issues in 2 different API endpoints. Groundcover will give you an API resolution of an issue that is occurring. So it's not granularity in the level of a workload. We give you a much higher granularity by identifying the specific API in which the error is occurring. By the way, API screen will show you the complete catalog of this workload, regardless of the issues presented. As you can see also, groundcover auto-identifies the UUID part of every API endpoint and cluster it, and identifies the API endpoint groups for you without prior knowledge or instrumentation needed. If I'll go to one of the issues, and let's take this one, this screen will take me to the traces screen of this API. Here, I can see all the sample of this issue occurring. One very cool thing about groundcover sampling logic is that we will not drop error samples. Every error that is occurring in groundcover will be captured and displayed here. So you have all the incidents in which the error has occurred. If I'll press on the trace, you will see the full body and the response. TLS is whether it's TLS or not, it doesn't matter, because groundcover ebpf is an application level sniffer, so TLS does not interfere with our ability to see the data, and that means it doesn't interfere for you to see the data. And you can see the headers, and as I said earlier, even here we bring all the context to you. So even in the trace tab, other than seeing the trace itself, you will see the Kubernetes event, in this case, the container info, which is what's relevant for the container. By the way, there is a single integration that is not out of the box that is applied in this demo environment, and this is groundcover's GitHub integration. So if you annotate your workloads with a groundcover according to the groundcover docs, groundcover will automatically relate the workload version to the merge diff in the GitHub page. So you can easily track what change introduced this trace error. The other two tabs are the logs and the context. So logs tab is also interesting because it will not show you all the logs from, let's say, from this container right now. It will show you the logs that are contextualized to the trace time frame, +5 seconds and -5 seconds. So on the trace you see here are heuristically tied to the trace error event, giving you a much less of frustration in searching for the log that might help you identify the issue. And the last tab, as I said, is the context tab, which will give you the context in Kubernetes. For example, what was the CPU and the memory consumption at the moment of the trace at the pod level, but also at the node level. So if the pod was saying that it had enough memory, but the node was behind the scenes suffocating, that you will see it right over with this screen. Cool. I'm going to jump to the API catalog screen, and after
No,
that,
maybe I just want to make sure we have enough time for the dashboards because I know everyone is really keen. Seeing you building a dashboard, I published a poll, and everyone is really excited. So just make sure we have enough time for that as well.
Yeah, sure. Yeah, I'm going to spend like 2 more minutes here in the API catalog, and then I'm going to the dashboard screen. So I just want to give a brief about investigating an error, but let's say we're not trying to investigate an error, but just want to get an essence of how our application is performing. Then API catalog is the screen you are looking for. API catalog is a screen that, as I showed you in the specific front-end workload, will give you a summary of how every endpoint in the cluster is performing. So you can filter a specific workload, a specific namespace, a specific protocol. You can do also a combination of those. And let's say you are looking into what is the slowest query you have right now in the cluster. So if you'll go to the PostgreSQL, for example, and you will order by P95, you can see an opportunity, you can see a fishy query that will show you that sometimes have like a latency that is 6 times larger than the P50 for that query, giving you a strong hint that 1 in every X queries is very problematic and might worth optimizing. Of course, this page takes you, once you press on an API like that, for example, it will take you directly to the traces screen, which it will give you a sample of those prolonged requests. In this case, let's see, I can sort by latency, and I can see the specific request that for some reason took 2 minutes for Hotel Collector to respond to. Awesome. This is kind of a brief of groundcover native capabilities. And as Chezi mentioned, as Yechezkel mentioned, and as this main part of this webinar is to demonstrate the costume capabilities. So all the metrics you've seen so far are fetched and processed and exposed using 2 databases that are installed as part of groundcover. Those are Victoria Metrics, which is used for all the metrics data, and ClickHouse, which is used for the logs and the traces you've seen so far in this demonstration. Those databases are not just accessible for our native user experience, but also are exposed and accessible for you using our managed Grafana offering. So whenever you install groundcover will automatically display. Sorry about that. Just want to open the right dashboard. Cool. So The moment you install groundcover, you will not just get the groundcover native user experience, but you will also be onboarded to a managed Grafana supplied by groundcover with 3 exemplary dashboards that are all using groundcover metrics behind the scene. And the data sources that are have been installed in your cluster will be automatically onboarded to this managed Grafana. So once you install groundcover also takes away all the headache of setting up new dashboards, if you need to set up an ingress for them and connect them and make them
because
accessible to other people in the organization.
Yeah, I just want to emphasize that, like usually, the Prometheus or whatever you're using are inside the cluster, and the Grafana is somewhere externally, and then you need to integrate between them. So groundcover does that out of the box for you.
Yes. And of course, the moment you will introduce new clusters to groundcover, they will pop up here, just like they will pop up in native groundcover. So I went to one of the supplied read-only dashboards that you will see in. So if any of you, for all of you who installed groundcover, you will be able to access the same dashboard that I'm seeing right now, just with your cluster and your namespace and your workload. And this is the same front-end workload we saw in the native groundcover experience with a slowest API chart, error rate by API, P50 latency, and as such. We also provide dashboards for cluster resource management and also for custom metrics integration, which I will show in a bit. Cool. So other than our supply dashboard, the whole reason for this feature is not just to flex that we can supply Grafana in an iframe and interact with our own metrics. The main idea of this feature is to help you integrate, to define your own question, the question that matter the most for you. So let's take one example for it. Let's build a dashboard for one of those questions. I'll press on new and I'll go to new dashboard and I'll press on add visualization. As you can see, Grafana opens up with a panel building screen. And I can choose the data source. I'm going to build a data source on it. After that, by the way, I will not cover it in the webinar, but I will show you it. I will not do it myself here, but I will show it in the end. This can also be a parameter in the dashboard you will build. So the dashboards can be easily multi-cluster. It doesn't need, the panel does not need to be binded to a specific cluster. And let's say I want to build a dashboard that will show me the average latency, P50 latency of every workload in the cluster. So I'm going to bring
I just want to stop you because we have a question over there. The question is, are there any more default dashboards and default alerts in the plans for new future? I know you're constantly working on new things, so any thoughts about that? Any thoughts about new dashboards?
It's a very good question. Yeah, we're constantly adding new dashboards and editing and modifying existing dashboards. I will show you even like one new example that was introduced last week, and this is in the Kubernetes cluster resources. We added a disk usage dashboard, a panel. I will show you it in a bit. Just a moment. I will open the cluster resources, and I think we had it here, right, Haskell? Or I'm confusing and we had it in another class, maybe it's in the workload golden signals.
Yeah, so I can't see your screen anymore. Like it's not live. Maybe it's a different window. Or it's
sorry, yeah, it's in a different window. I will skip the awkward search for the new metric we added, but I'll just briefly say, yeah, we add those. And one of the cool things we're working on is adding dashboards for open telemetry integrations. We are having this existing with our customers, with some of our customers right now. And once we are going to identify like the a win that is a consensus and will be efficient for the majority of our customer, it will be pre-built into the dashboard supplied by groundcover and will be automatically updated to all our customers. And if you have any specific dashboard that you think it's a good idea to bring out of the box, feel free to share it in the community. We're very positive about adding features, specifically those that are coming from the community, and we can add it in a. It will probably be able to. We will probably be able to add it very quickly. I'm
cool.
going back to the query.
I think you're in the wrong data source. I think you're in the wrong data source. You're using the wrong cluster.
I'm using the dev.
Maybe?
Yeah, you're correct. I moved to the demo one. Cool. So let's do a bit of a PromQL 101. So in PromQL, by the way, those might pinpoint this cool trick here. As you can see, the data source is registered as a Prometheus, although we use Victoria metrics. This is one of the reasons we chose Victoria metrics to be our weapon of choice for metrics, because Victoria metrics is a polyglot database. It is able to ingest and also expose querying in other platforms, query languages, and supported formats. So Victoria metrics is for Grafana is 100% compliant Prometheus data source. Grafana has no way of knowing it's actually Victoria metrics and not the actual Prometheus. From your perspective, this means also that you can use groundcover to ingest metrics that are not only Prometheus derived, but also if you use, for example, Telegraph or Datadog even, you can push the metrics to our Victoria metrics and they will pop up immediately in the groundcover metric browser. This is the costume metrics integration. I'm going to elaborate on that in a second. So once you will open the metric browser, you will see all the groundcover generated metrics presented for you. All these metrics, it's important to mention, are fully documented in our docs with all the available labels and the type of them. So obviously they are counters, but it will be, with the docs, you will be able to identify what is the metrics that will give you the answer for your question. Something cool about groundcover metrics, as you can see, and if you have experience with the Prometheus metrics in the past, there are not that many, and that is because groundcover is using high cardinality metrics in a very efficient way. We are trying to bring you all the context to the labels, so you need to know a small subset of groundcover metrics to answer 99% of your question. No more like thousands of metrics to get familiar with in order to answer your questions. Cool.
No, we have another quick question. It's what were the reasons to choose Victoria metrics over native Prometheus?
So this is a great question. I think Chezi, you are the database master, and you'll probably be the best to answer.
So basically, I had a feeling you're gonna spin it around. So basically, what we did is we're trying to optimize the system for our customers, right? So what we're doing is we are constantly benchmarking every open source database out there constantly. So we've checked. I think I've been benchmarking maybe 15 or 20 databases, and I'm constantly doing it every week. And Victoria metrics has by far the best performance of all of them. So we chose that just to give you guys the best experience and also the cost-effective solution there is today.
It's important to say that it's we argue in the R&D if it's also only for a customer benefit, or Yechezkel is trying to see how fast we can migrate the database given he found a viable option. But it's probably the best of both worlds. Cool. So this PromQL query is so by the way, if you are not familiar with PromQL, Grafana has very extensive docs on PromQL. We intentionally used PromQL because although every alert and dashboarding system have a learning curve, this is the most widely accepted and experienced learning curve out there. A lot of data, a lot of community around building queries. So other than our support channel, you have a lot of pages in Google and ChatGPT knowledge on how to build PromQL queries with ACE. This query is using the groundcover resource latency seconds. This metric counts the latency in second for different APIs, for all the APIs in the cluster. They are all labeled with the container image, the namespace, the workload, and the path itself, and many other labels. I will open it here on the side to show you all the labels available for you for asking. You can use the method, type will be the protocol, there are some internal labels, of course, but also response status you can use, return code. If this is a Kafka type of metric, the topic here will be that you can get a topic resolution for this latency, for this metric and such. So I took the metric and I look for all the P50 metrics of type HTTP, and I wanted to get average of the workload, namespace, and cluster path. If I run this query, I ran it on the last 6 hours. As you can see, Victoria Metrics is quite fast, but let's do a more sane value of last 15 minutes. I will see all the different paths in every namespace and I intentionally grouped it by namespace as well, and not just by the workload name, because a lot of one of the questions this metric can help you answer is, let's say you're doing some sort of A/B testing or want to compare a workload specific API in one namespace to its older version nephew in another namespace. So this is why I grouped it not just by the workload name or just by the API, but also by the namespace and the workload name altogether. Once I have this query up and running, I can run save. And since this is the first panel in the first dashboard, I will give this one a name. Let's say API latency. Sorry for my Hebrew dashboard. Latency benchmarks. Nice. I'll keep it in the general folder, which is quite messy after all the webinars, but nonetheless. And as you can see, I now have an API latency benchmark dashboards. I can add more panels revolving API latency benchmark in this screen. You can share the button with your colleagues. This link is a fully working link. So other people in the organization, you can copy and paste this link, send it to them, and then they will be able to view the dashboard we've just built together. It's important to mention that if you have dashboards from other place that you want to import here, you can also do it with Grafana. So if I'll go back and I will press, instead of a new dashboard, import, you can just import via the JSON export. You can just import the exported JSON file of an existing dashboard. An immediate question comes to mind. The dashboard is relying on metrics that the ground cover doesn't have out of the box. So how it will work? So as I said earlier, and this is also one of our latest features, ground cover is fully compliant with ingesting your custom metrics by simply opting in a single value in our Helm chart called custom metrics. Ground cover will deploy a Victoria metrics agent, which is a very, very lightweight metrics scraper that will auto-discover all the Prometheus annotated metrics in your cluster and will ingest them to the ground cover Victoria metrics. The following dashboard I'm going to show you here, and I'll show it in the Karma name, in the Karma data source, is dashboard that is fully reliant on Kubernetes state metrics deployment. All the metrics that are generating this dashboard are completely non-ground cover metrics. that groundcover just ingested into the groundcover Victoria metrics database. Moreover, this entire dashboard is just an import of a community-built dashboard, Cube State Metrics dashboard from their GitHub repository. So once you incorporate your custom metrics or custom metrics of third-party tools into groundcover, you have the ability to import dashboards from all over the community of the monitoring community directly into groundcover. I'm going to now show you how to build an alert using groundcover. So if I'll go back to I think it's a good place maybe to pause for a bit if you have any question, because maybe it was a lot to take in. So if anyone have questions so far or one?
No, we have another one. We have another question. So Grafana support Explore, where you can query different DB for debugging or different correlation exists between metrics, logs, and traces. The groundcover tab for Explore, where user can deep dive establishing trace correlation with logs or metrics, and not relying on supplied dashboards or building one as such. I think it's a good time to introduce the Command K feature.
Yeah. So Command K is a secret. It's a hidden, but it's a hidden shortcut in our managed Grafana, but basically lets you use the Explore page, which will just let you see all the data sources, the groundcover data sources from all your groundcover installations, and then give you like a free metric browser experience. By the way, our logs and traces are also accessible through here through the ClickHouse data source. So if you're familiar with SQL, you can just run a simple ClickHouse query here and see even logs within the managed Grafana. Is that answering the question?
Amazing. So you just replied amazing.
Nice, cool. Glad it was. I'm glad it answered the question. Nice, cool. So, with your permission, I'm going to go back to creating an alert. So, if I'll press Edit on the panel, I'll now take a shortcut to creating alerts, which I believe is more useful. But you can also create alerts straight away with groundcover. But my preferred method of creating alert, which I will explain in a bit, is using an existing panel. This will allow you to see like historical data of when the alert has been fired, and not just relying on the alerts. Not just relying on the Slack channels alert, for example. So if I'll go to the alert tab in the panel we just created, and I will press create alert rule from this panel, Grafana will take me to the alert building page. And let's say we'll call this alert. Let's say we want to do an alert on latency that is bigger than 1 second. This is going to be like a security test for Grafana if they will accept this scarf for a rule name, this character for a rule name. But we'll see once we'll finish with setting up the alert. Nice. So as you can see, Grafana automatically imported the query I've built here, which also is another reason why I think you should start build them with the dashboards, because it will allow you to get a more immediate feedback if your alert is working or no, if your query is working or no. And then once you press create alert from the panel, it will use the working query. So if I'll press run queries here again, you can see that I get the same result as earlier. And now it's time for a short Grafana Alerts 101. So when we define alert in Grafana, out of the box, there are 3 steps for an alert, let's say an alert pipeline. First, step A is the actual query that will produce the data that will be used for the alert. The second phase is a reduction. What values from the alert are we looking to sample? And the third and the last phase is the threshold phase. The threshold phase says at what values I should start fire the alert. As you can see, So we're using an average query. So indeed, the correct reduction will be to take the last value, because the query itself is already producing an average. If I would have used, let's say, a rate query, the correct thing to do will probably use the mean one, because I would like to take the average over the rate function in the last 15 minutes, not just the last value, because the rate can drop. So I will definitely take the last one here. But I want to use a threshold, so I call the alert. I want to take all the latencies that are bigger than 1 second. So the correct thing to do will set the threshold for 1. And if I run the queries again, you can see that only 2 alerts are now firing, the API checkouts that are indeed well over 1 second latency in the last 15 minutes on average. Once I have my threshold defined, I can move on to step 3. Now, step 3 is, let's say, in Grafana community, is the notorious phase. It's a bit confusing, also in terms of UX and also in terms of terminology. But I will try to keep it as simple as it can be. And if you have any question and something is not well understood, let me know. Completely plausible, as this is a very tricky part in setting up alerts in Grafana. So when we define alerts, we need to have a strategy for mitigating false positive. Grafana strategy for mitigating false positive is to identify a consecutive number of samples that produce the turn out positive. How this is done in Grafana, there are two core terms. One is the evaluation group, and one is the for interval. The evaluation group tells Grafana what is the interval Grafana should sample this entire procedure, A, B, and C. And the for loop is telling Grafana after how many samples should I treat this as an actual alert. So let's say, for example, the latency one. I don't want to wake up someone who's on call if there was a latency spike for a single moment in time and it all turned around great for hours to follow. This is something worth investigating maybe after the weekend is over, but not something that is worth rushing someone to the phone. However, if this latency problem is consisting for more than 5 minutes, then yeah, I definitely want to wake someone up and to have them check what is going on. Hopefully with groundcover as well. So when we create alerts, we need to create a folder alerts. So I have already predefined the alerts, but when you are going to create your first alert, this folder is going to be empty. And what you'll need to do is to start writing a folder name and press add new. Press enter to create a new folder. We'll generate the folder, and as you can see, I will have a folder created notification. The second part, this is the evaluation group. Here we will put the time interval we are looking to use for sampling rate. In my case, I want to use 1M, which means 1 minute, and I'll press end new. And as you can see, an evaluation interval has been created, which will be evaluated every 1 minute. 4, which is right here, 5 minutes. So only after 5 consecutive intervals of positive match for alert, the alert will fire. So by default, the alert rule, if it was created from a dashboard, will contain a dashboard URL, which means the alert will be fired directly with a link for the dashboard that the alert was set up for, which is another reason why I think it's very convenient to set up alerts from dashboards. Step number 5 is regarding alert routing. I haven't covered it so far. I'm going to touch it in a bit. But basically, when you set up a contact point, a notification policy in Grafana, you can decide to direct an alert to a specific team, for example, using labels. So if I had, let's say, type and I would write here production, then I have in the behind the scene, I might have a notification policy that routes all the alerts from type production to the SRE on-call channel, for example. And now, I'll not need this label here now, and I'll now press save and exit, and rule latency has been created. As you can see, after I created it, a small heart, green heart, was added to the panel, and which signifies that currently the alert hasn't been fired. Of course, in 5 minutes time, this alert is indeed going to be fired, and Grafana is going to annotate this dashboard with the moment of the alert has been fired. And if I have my contact policy set up correctly, the alert will also be fired to my selected contact point. Grafana, out of the box, support all the major vendors for alerting. We support email, we support all the suppliers here, PagerDuty, Slack, Telegram, ServiceNow. You can configure any one of those and use them for firing your alerts using groundcover. If I'll press on the alert screen, you can also see the alert we created right here. It's now in state pending, and in a few seconds, the alert is going to be sampled, and after 5 consecutive samples, it is going to be in state firing, and the alert will be fired to the selected notification policy and contact point. And that's about it, guys. We have time for questions. Feel free.
Thank you, Noam. It was really interesting, and it always amazed me to see, how simple it is after you get all the building blocks right. How simple it is to just build your own panels and then create meaningful alerts from that. So thank you for that. I think we don't have any more questions. So I just want to thank you all for joining us today. Thank you, Noam. It was really interesting to mix it up a bit and have more technical, geeky, as you describe it, discussion. Yeah, and
My pleasure.
I hope to see you soon in more technical and deep dives.
I'll be glad to. Feel free, everybody, to reach us in the community for any further questions. Our support channel is very vivid. You will see people from all over the world asking why we use Victoria metrics, how to set up alerts, how to define SQL queries in our ClickHouse data source, revolving logs, which are also alertable using groundcover. If you need any help with installation and opting in groundcover features, we are there.
Great. So thank you, everyone, and see you next time. Bye-bye.
Thank you. Bye-bye. Good night.